Hello and welcome to my channel. The goal for creating this video was really to provide a simple guideline or introduction to optimizing our Go projects. Often we see repositories in the open source world that claim to improve performance of our applications if used instead of some of these standard Go packages. For this purpose, I'm going to create a super simple HTTP server with one echo endpoint that receives a relatively large JSON payload, deserializes it or unmarshals it in Golang terms, then serializes the same data and sends it back. I've taken the JSON payload from the benchmark tests in JSON Iterator repository, which, surprise, also claims to improve the performance, in this case of JSON encoding and decoding, and could be used as a drop-in replacement for the standard encoding/JSON package. I'll put the server under load next using the Vegeta tool to see what the QPS will be. Then, I will use the easyjson package instead of the standard encoding/JSON and observe its impact on performance. Please note that this contrived example does not absolutely simulate a real-world scenario. As I mentioned earlier, it's just a demonstration of some of the tools available to us developers. But without more ado, let's jump into the code. For the sake of time, I've already created a project with a few necessary files. The person package contains the struct for working with the JSON payload I mentioned earlier. It is relatively large, so I wrote it before recording the video. I've put the link to its GitHub repo in video description in case you'd like to try things out by yourself. There's also a test file to make sure encoding and decoding works with the person struct. Let's run the test to make sure everything works as expected. Now, let's actually start developing the HTTP server. First, let's create a directory and name it cmd, and inside that, another directory called stdjson, which will be hosting the main.go file. The server is going to have only one endpoint. It'll be accepting post requests, decoding the JSON payload from the request body, then encoding and sending it back as a response. Let's make sure we're only handling post requests with our echo handler. Let's go back to our main function and finish where we left off. Now, let's run the server and make a dummy post request to see if it works. Yep, it works. As you can see, the server is returning back what it receives. Seems like there's a problem with the print statement, so let's go back and fix that real quick. There you go. Next, let's put our server under load using Vegeta. Now, I've already created a sample JSON payload to be used by Vegeta to make post requests to the server. But in order to make Vegeta do that, we need to create a targets file and describe everything there. Next, let's create a scripts directory to put all of our helper scripts there. I'm creating the attack.sh file to command Vegeta to start issuing requests at my server. For that, we use the Vegeta attack command and pass the targets file we created previously. -rate0 means make as many requests as you can, and -max-workers determines how many concurrent workers should be making these requests, and finally, the duration of load test will be 1 minute. We'll also store the results of Vegeta attack command in results.bin, which will be useful later on. And with the help of Vegeta report command, we get a nice report about the results of this load test. I run the attack script now and wait for 1 minute to get the report from Vegeta. Apparently, 150 workers were too much for the server to handle, so let's reduce that number to 100. In the report, we get a lot of useful information, such as the total number of requests, request rate, and throughput of our server. Currently, the server can handle 21K requests per second. There's also information about the latency of requests. The two useful ones, in my opinion, are the mean and P99 latencies. P99 in this case is 34 milliseconds, which means 99% of the requests took less than 34 milliseconds to complete. Vegeta also provides a plot command to display how latency changes over time visually. This is where the results.bin file comes into play. Next, let's go ahead and use easyjson and see its impact on performance. Let me close the unnecessary tabs first. So now let's go ahead and create an easyjson.sh file to generate the necessary files for our person struct. Make sure you install easyjson before running the script. Let's create another main file for a HTTP server, this time with easyjson package. So just copy the contents of our previous main.go file and paste it in here. And let's switch the standard encoding JSON package with easyjson. We're going to use onMarshal from reader to decode and Marshal to HTTP response writer for encoding. Let's run the new server and put it under Vegeta load. Let's do the same to the previous one to compare the results. You can now see that the throughput of the server with easyjson is 25k requests per second, whereas the server which uses JSON package from the standard library has a throughput of 19k requests per second. There's also a huge difference in P99 latency. easyjson is almost 3 times faster. You can check out the Go doc for easyjson for more information about its API. I've put the link to the repository in the description below in case you want to check out the code. If you're interested in why we're getting this performance boost, let me know in the comment section whether I should create another follow-up video and investigate this with other tools in Go's toolchain like pprof and tracing. Please make sure to subscribe to my channel for more Golang and Cloud Native related content. Thanks for watching. Stay home, stay safe.